Hello folks, today we will see how AccuKnox helps secure 5G workloads running on Nephio infrastructure. Nephio is a Kubernetes-based intent-driven automation of network functions and the underlying infrastructure that supports those functions. It allows users to express high-level intent and provides intelligent declarative automation that can set up the cloud and edge infrastructure, render initial configurations to the network functions, and then deliver those configurations to the right cluster to get the network up and running. We have a demo setup based on Nephio R1 release. It includes the Nephio uh, management cluster setup to deploy with the regional cluster, 2 edge clusters, repositories for each clusters registered with the Nephio, and config sync setup to pull from those repositories. There's inter-cluster networking between those clusters as well. KubeArmor is a cloud-native runtime security enforcement system that restricts the behavior such as process executions, file accesses, network operations of containers and virtual machines at the system level. KubeArmor leverages eBPF for deep observability and LSM framework for policy enforcement. KubeArmor helps with the continuous monitoring of application behavior, securing service endpoints in 5G control plane, 5G control plane hardening using FIGHT and NISA, and multi-layer zero trust policies for 5G. Let's focus on the free 5GC deployment and see how KubeArmor helps securing it. We have a 5G component running on regional cluster and communicating via the Kubernetes default network. We have SMF and AMF here running on the regional cluster as well and attached to the secondary Malicious network as needed. We have the UE and UPF on the edge cluster and attached to the secondary Malicious network. There's Web UI and MongoDB, which act as supporting services. We have a register subscriber in the free 5GC scope and UE Ransom running on the Edge 01 cluster and simulating a G node B and subscriber UE. The Web UI serves as a web-based tool designed to manage user equipment subscription data. It plays a crucial role in aiding the free 5GC core network manager by facilitating the configuration of UEs and providing the ability to monitor the status of activated UEs. Let's see the Web UI in action. Here's the Web UI admin dashboard. It provides you with the user equipment data, what are the registered equipment, whether it's connected or not, what are the subscriber list. It lets you even manage, add new subscriber if needed. Let's add a sample subscriber in, and you will be able to add a new subscriber accordingly. You can delete or modify it. It has the entire infrastructure web interface to manage user equipments for you. So KubeArmor provides you with the granular view of what's happening inside the Web UI when you do all these. So it has all the file data, what the egress data is, what processes are accessing what files. We can see which all processes are accessing what files and network primitives inside the Web UI pod. We can see how primarily the web console binary is responsible for important file accesses and network interaction. Let's try to harden our services here. KubeArmor provides you with a recommended set of policies which will help secure your workload based on frameworks like MITRE FIGHT, PCI DSS, NIST, and many other frameworks. Let's take a look at one of the recommended policies that KubeArmor does is package management execution. So deny execution of package management process in the container. Applications usually come with all the requirements bundled with them. So any package management execution is a runtime threat. Let's see it in action. What if I go ahead into the container and try to add a malicious binary here? I got a permission denied. Also, KubeArmor provides you with a container alert with all the context needed, which cluster, which namespace, which was the deployment. This was the policy, had an IST tags, bin busybox, APK, everything was denied. So you have the entire context to go ahead and debug or take remedial actions on where this threat might have been occurred. But what if your application itself is compromised? We have a compromised service which is turned root. It will then have access to all the networks from other network functions in your cluster, running in your cluster, or any network. Maybe it is connected to other Multus networks as well, so it has access to your entire control. For example, MITRE fight recommend it talks about a threat called network function service discovery, such that an adversary may query the network repository function to discover restricted network function services to further target that network function. NRF is by design open to connections from other network functions. So if you have your rogue NF, which is the web UI in this case, it can access to NRF and abuse it to identify and target one or more other network functions of interest. It is possible, for example, to find out whether an operator provides services to a certain customer or whether a user is also part of a private slice. Example, Department of Defense. This is slice isolation assurance loss with this threat. So, to showcase this, let's try to. I am inside this web UI pod and I try to communicate with the NRF as the tactic suggests, and I could get the information about UDM, which is another network function, which is how the tactic suggested is a security concern. But how do we protect against it now? We have multi-layer zero trust policies generated by KubeArmor for us. We saw in our earlier summary which is the binary which is actually responsible for accessing the sensitive access and file. So KubeArmor generates you a policy around on how only this binary is able to access network protocols like TCP, UDP, RAW. Similarly, for other network functions like gnode in this case, only UERAN sim config should be only be allowed access to the GNB binary or only the network. So multi-layer zero trust policies for 5G help us with network microsegmentation. It provides with least permissive access to sensitive assets, and it helps us with process whitelisting. Let's try to apply the zero trust policy generated for the web UI service. As we can see, only web console is able to access sensitive assets and network primitives. Let's apply this policy. We have applied this policy, and now if we go ahead and try to access this network primitive, we get a bad address. And we would have an alert saying the socket creation was denied because it's a zero trust policy. We don't know what's the policy it is against, but we know that it is for inside the web UI pod, and the entire context is available in general. So that's how the least permissive zero trust policies help secure against unknown attacks that may be exploited by any attacker. Let's talk about a few more attack scenarios in the same context. This is a tactic called network function service discovery. Similarly, an adversary may query the network repository function to discover restricted network functions. We already secured against it because now uh, because now that we have the zero trust policy, we tried to connect with the NRF and it could not be accessed because any malicious actor is not allowed to access the NRF. Similarly, registration of malicious network function is not allowed. A legitimate network function can go rogue and can be used to register itself in the NRF. By having an unauthorized network function installed or activated, an adversary may gain access to resources in the network to perform other types of attacks such as denial of service, the distribution of malicious software, or obtaining sensitive information. But as we talked about in here, since the NRF or any other registration function is not available, the attacker won't be able to register any rogue NF, any malicious, and any network function which has a malicious intent. And in turn, the further attack is contained for us. This is how KubeArmor applies the policy. We have the web UI pod, which has web console binary, and then a malicious binary, which is from the attacker and which is trying to access the NRF and compromise your entire 5G control plane. But since we have the zero trust policy applied, the attacker itself is contained and is not able to take any action. A few other tactics include unauthorized access to the network exposure function, an adversary controlling an external application function, such as the web UI, may present a fraudulent OAuth access token to access network exposure function services. The standard mandates TLS between NEF and AF and authorization via OAuth 2.2. But based on the scan report from KubeArmor, we see that all the free 5GC services here are using plain text. So TLS itself is not mandated. So token fraud itself is possible, but we have a policy in place to prevent access to the service account tokens here. So if I go ahead and try to access the service account token, we get a permission denied and we get an alert accordingly that service account token was tried to access and it was permission denied inside the web. So we prevented the network exposure function fraud using token fraud. Final tactic that we will talk about today is G-Node component manipulation. An adversary may compromise a component of G-Node to affect the radio network configuration. G-Node is the entity where the user equipments route their traffic to the control plane, and any unauthorized access to and manipulation of the G-Node component can be carried out by a supply chain attack or as a relation of malicious updates using operators management and deployment tools. It further allows the application with standard interfaces to the agents outside the control network that can also read data and send configuration changes. Any compromise of any of these components can potentially cause unintended changes to the network and expose user information. So if somehow the network itself inside the G-Node network configuration inside the G-Node piece, you may be onboarding unrelated user equipments and which may have malicious intent towards you. So how do we prevent against this? We already saw that we have a zero trust policy for this, which is this, and we have limited access to the UE ransom config file, and similarly the NRGNP to the NRGN. So if I go ahead and apply this, we successfully applied the policy. And if I now try to access ls itself is not allowed to the UE ransom config file, and we get an alert accordingly. But if I go ahead and try to access the NRCLI, which in turn accesses the config to fetch the details, it can still access it. So what Zero Trust Policies does is it allows you to whitelist certain entities, and certain entities here which are trusted to you. The like for example, the GNOP binaries itself are trusted entities, so they are able to access the config and act accordingly. But any other access is not allowed, hence securing yourself against unknown attacks, which may use uh, tactics like the GNOP component manipulation. We can also see that the UE itself can still communicate with the DNN, so the network routing of GNOP is working as intended even after applying the Zero Trust policy. So key takeaways from this is that 5G control plane is the new attack domain of interest due to multiple vendors deploying workloads at a rate and hence increased attack radius. One needs to isolate and microsegment these workloads. Zero Trust 5G is the ability to apply least permissive policies which help you secure against unknown threats. KubeArmor helps you provide deep observability using eBPF telemetry. It provides you with continuous monitoring for application behavior. It has granular auto-generated policies for container isolation. And it provides you with security best practices and hardening policies for your X application network functions and workloads. Thank you.